Very good day to everyone. I'll introduce myself as Neha Priya, working as assistant professor in IIMT College of Pharmacy. Today I'm present before you with a topic that is Flourimetry, and I guess my video lecture will help you a bit to learn about what does it mean. So the first thing which I need to start with is are the contents what are involved in today's video lecture. So the contents are as follows. First, we'll learn about what is Flourimetry along with its principle, then moving towards what is fluorescence and phosphorescence. And after that, we learn about what are the instrumentation involved in Flourimetry. And last will be the application in like in what sense we can use an instrument in the analytical techniques. So the first thing which you need to learn is what does it mean? Basically, what happened is, like as I have already told you in ultraviolet spectroscopy, what happened there was whenever a molecule gets an energy source of ultraviolet rays, it has moved from its low energy state to high energy state, or its ground state to excited state. In fluorimetry, atoms are involved in this. Basically, what happen here is when any atom gets any source of energy, it like we can imagine ourselves also when we have that energy to move, we go to places and visit that places. But at home we are at stable place, and at that place we are not at our stable state. So ultimately what we'll do is we'll get back to our stable state, and whenever we get back to a stable state, that time we'll only get back to a stable state when we are having less energy with us. So what happened there was a more atom gets an energy, and whenever it also gets an energy, it's moved to its unstable state. And when an atom is at its unstable state, it will try to move towards a stable state. Whenever the atoms will try to move towards its unstable state, from unstable state, it will exit out some energy source, and these energy source are known as luminescence. So what happened is this luminescence can be of two types, basically fluorescence and phosphorescence. And this fluorimetry works with fluorescence. It helps in examining the fluorescence of particular compounds or chemicals. So this is what fluorimetry's introduction we can say is. What happened here is a molecule gets some energy source, it's moved from its stable state to unstable state, and after moving to the unstable state, it tries to get back to its stable state. And whenever the molecule will try to get back to its stable state, it will exit out some energy, and that energy is termed as luminescence. And these luminescence can be of two types, basically fluorescence and phosphorescence. And this fluorimetry works on the principle of determining the fluorescence of any other compounds. So what happened is, whenever, for an example, whenever a atom will get this energy source, and within instant time, it reflects out that. I will quote one example for that. Whenever we are moving with our bikes or anything to any highway, we have seen the radiators there. Whenever our white light has been given to that radiators, they emit out some light at an instant speed. You can term this as fluorescence, because what happened there is whenever there is an energy source given to that radiators, they emit out some radiation to you. And when we stop that energy source, they do not have any color, or they don't emit out any color at that point of time. So basically, fluorescence is an instant emission of light or instant emission of luminescence. And the second point which you need to learn about fluorescence is it only gives out the light, or fluorescence. Material will only give fluorescence when there is an energy source involved in that. If we are not giving any energy to the atom, then they will not emit out any radiation at the time. The temperature here will be a moderate temperature compound will give. And the third thing which you have to learn is the singlet state is involved in fluorescence. As there is an instant emission, thus the molecule only went through one phase, that is the singlet state. So the molecule which works on the singlet state will give us fluorescence. The second things involved in luminescence, as I've already quoted, is fluorescence, the second type of luminescence. It's just an opposite of fluorescence. What happened here is when we give any light source, for an example, if I'm giving any light source and to an atom, after a period of, it will give me some radiation, but the radiation here will be delayed radiation. I'll quote one example so that you can relate to it, is of tube light. Whenever we switch on the light, we give the energy to the tube light, it takes certain period of time to glow. And whenever you switch off the light also, it takes some time to get back to its stress state, or it will take a certain amount of time till then it will radiate some energy to you. So the first thing is delayed emission. Fluorescence is the delayed emission of light. Second thing is it only happens in the cold temperature. It will not happen in a moderate temperature. And the third thing which is involved here is fluorescence is basically, happens in triplet state. First, it will move into the singlet, then there will be an external conversion involved in this, and with the external conversion, it will move to the external state, and in external state is basically third triplet state, and after triplet state, it will come to its stable state. Thus, it will take certain amount of time to move towards all these phases, and that's why fluorescence is a delayed emission of light. So till now, I have only discussed about what is luminescence and types of luminescence, that is fluorescence and phosphorescence. Now we'll move towards the principle of fluorimetry. Here what happens is only fluorescence is involved. When we give, I'm repeating that whole process once more. When we give in light or energy to any atom, that atom will move from its lower energy state to higher energy state, or you can say from its ground state to excited state. And when this atom move from these states, move between these states, it will radiate out some energy. It will, they want some energy, and that energy will be of the invisible ultraviolet energy, basically from 250 to 400 and when it will come to its unstable state, it will try to get back to its stable state. At that time, it needs to release some energy to get back to its stable state, and that energy has been transferred in the form of 400 to 2000 nm. And this happens, then that's why we are able to see that radiation, because the energy because the radiation's wavelength is more than the radiation given. So the difference between the radiation or energy given to our atom and the radiation they are emitting is known as Stokes shift, because the wavelength varies. The variation between these two wavelengths is known as Stokes shift. So whenever it comes to that, and when it comes to that, it will radiate some energy. In fluorimetry, what we do is we just examine the amount of radiation exhibited by the atom. We put our molecule, we put our sample into the fluorimetry, and we get the result of the fluorescence or given by that molecule, and it will help us to get the molecules who have a better fluorescence. Or suppose I want to make something in which I want to have fluorescence activity, or I want to have show some you know have some fluorescence activity, then I'll go with this instrument to find out the fluorescence of any chemicals or any samples in that. Next, we'll move towards the instrumentation involved in fluorimetry. I'll discuss one thing with you, that is, in all the spectroscopy parameters, one thing is common. If we are not giving radiation source to anything, then it's not spectroscopy, because the first thing which I have told you, or which I have mentioned to you in the earlier classes or earlier things also, was that spectroscopy is whenever we give an EMR radiation. So the first thing in instrumentation of any spectroscopy will be the radiation source. Here what happened is radiation source is the first part. The second part is your monochromator. There in other here there will be two monochromators involved. First will be your excitation monochromator that will excite the radiation to go towards the sample, and the second will be your emission monochromator that will emit out the result to the detector. One thing has changed out here is the instrumentation is a 90-degree form. It's in the 90-degree form because we don't want to get the result of the radiation, EMR radiation transmitted or absorbed. We want to get the result of the next energy or the other energy that has been exhibited by your molecule. That's why we are having this instrumentation on 90-degree, because in 180-degree we'll get the wavelength which we have been given to the molecule, and we'll get the result of how much energy has been absorbed or transmitted by the molecule. But in 90-degree we'll get the radiation that has been exhibited by the molecule. And after that, detector will detect the radiations, and it will give to the amplifier will make it readable, because the results will be very complex. So amplifier will make it readable or amplify the result for us, and last will be a readout unit in which we will get the result. So the new thing which has been introduced in fluorimetry is the fluorimetry instrumentation will be in the 90-degree format, because I have already told you to get the radiation emitted by the sample, not to get, because as we don't require the emission which we have given to the sample to get at that point. So the first thing in instrumentation of fluorimetry will be the source of light. And the thing is, in all the radiation source, what happen is, if we go in journal, we take one hollow cathode cylinder. In that hollow cathode cylinder, we fill our gas. For example, we give up a mercury xenon gas, we give our He gas in tungsten, we give our mercury gas in mercury arc lamp, and by giving that, we like put that gas in hollow cathode cylinder at a very high atmospheric pressure. As the atmospheric pressure is high, so the gases are already in their activated form, and when we give the energy to the same, the gas molecule will collide with that energy source, and when they collide, they'll generate one spark, and that spark has been used as a radiation source in all the spectroscopy techniques. So basically, the first thing here will be mercury arc lamp. Mercury arc lamp, you know, as already you have been, taught that mercury arc lamp is the most versatile detector, as it is the most accurate one. But the problem with mercury arc lamp is it will not, like, for in a long period of time, you can't go with mercury arc lamp. It can't be, operated for a big operation, so you can't use that, because it will get heat up, and whenever an instrument get heat up, then it will cause certain variations within its radiation. And the one thing which need to be taken care of by placing any radiation source in your instrument is the radiation source should emit the same wavelength continuously. The emission should be regular. It should not be changeable. It should not vary, and the temperature should be maintained, because if there will be heat up in the instrument, then it will certainly cause certain difference between the radiations. The next one is xenon arc lamp. The thing which was default in mercury arc lamp, xenon arc lamps, help in solving that. As in xenon arc lamp, the temperature will be maintained, but it is not as much as accurate as mercury arc lamp, but it is accurate. So we can go for it for a longer period if we have, longer period of, if you want to use our instrument for a long period of time, we can go for it. The last one is the tungsten lamp, or you can say the first thing radiation source which was introduced by us humans to the machineries was tungsten lamp. As we have already know, you already know the tungsten because of your lights and everything. So the same process has been involved, and that's, you just need to learn about the general principle involved in radiation source. That is, at high atmospheric pressure, we give our gases to a hollow cathode cylinder, and when we give energy also, then there is a collision between the molecule, and whenever two molecules collide, there is a spark generated from the same, and that spark has been used as a radiation source in all the instrumentations in spectroscopy. The second thing is here is filters and monochromators. The most important thing, monochromators are used in converting polychromatic into monochromatic light, as you already know. But here there are two filters that are being used in this. The first one we can say is primary filter, or the second one you can say is secondary filter. The first one is basically that will help in getting the sample, the UV radiation, and the second one is the secondary filter that will help the sample to transmit that radiation to the detector. So you can say the first thing will be the excitation that will excite the first one will be the excitation filter that will excite the radiation to go towards the sample and do all the process in fluorimetry. And the second one will be the emission or the capturing filter that will, capture all the radiation and make it easy to that radiation to go towards our detectors. Same goes for the monochromators. Excitation monochromator provides suitable radiation for excitation on molecule, and emission monochromator will isolate only the radiation emitted by the fluorescent molecule. Here is what is important, because that monochromator will separate out the wavelength given by us to a molecule. The energy which was only emitted out by that, the energy which was only emitted out with that sample has need to be taken care of by this monochromator. So so the thing in fluorimetry which you need to have in your mind is the instrumentation here is in 90-degree, and the emission monochromator will emit out or emit out all the radiations, fluorescence radiation, and give it to the detector. Detector will detect it, and further it will modify, you can say it was amplified, and the readout unit will read it. The second thing here is sample cell. Basically, sample cell here are basically they are liquid samples, and made up of the sample cell are made up of pods, and same as UV, the qubits are used over here. Or the thing is here a cylindrical sample, cylindrical or the qubit like cylinders are used over here. So rectangle or yeah, you can go with cylindrical too. Now the third last thing is here is detectors. In detectors, you need to understand that there are two things involved in this. The potential difference generated between two cells, that is positive, negative, cathode, anode, are analyzed in the detectors, and that helps in getting us the radiation emitted out by the sample. So there are three types of detectors that are generally used over here. The first one is photovoltaic cell. The second one is photomultipliers, and the third one you can use photocathode. What happened here is in photomultiplier, photovoltaic, you can call it as barrier layer cell. The word itself explains barrier layer. That means there are layers in this, and one layer is working as a barrier over here. So the layer that is working as a barrier over here is selenium. And what happened there is whenever radiation comes to that place, this first place is iron, the second one is zinc. What happens is selenium is in the middle. These two layers are different. When the radiation comes toward it, the selenium hold the radiation and give it to the upper layer only. So the difference between this cathode and this anode varies, and when there is a potential difference generated by the detector, it you know capture that difference and give it to the amplifier to amplify it. So in this way, the detector does its work. There are, oxide layer, there is oxide layer over here, oxide layer, copper plate. But the thing that needs to have in your mind is selenium here works as an barrier over here. The second thing you have to keep in your mind is all the detectors work on the principle of potential difference. Next is PMT, the most used detectors over any spectroscopy technique. Like if you don't remember any detectors over in their exams, then you can go for PMT because it is used in all the spectroscopy techniques. What happened here is there are certain diodes present in this form over here. Whenever radiation comes towards it, it goes towards this multiplier with each diodes. And as this multiplication works, for an example, here you have one cell, here you have one cell, there's a potential difference between these two cells. And when there is a potential difference, as I have already mentioned, that detector detect that potential difference and give it to the amplifier to amplify that, and then further we'll get the result. So the thing is, in multiplier, there has been a multiplication, 2 into x multiplication of radiation uh, by by the diodes, and by that we get the result. So these are the detectors that are being used in photomultiplier tubes. The last thing is, like, we have learned everything about fluorimetry. We have learned about what is fluorimetry. We have learned about what is luminescence, types of luminescence, fluorescence and phosphorescence. In fluorescence, singlet state is involved, and in singlet state, basically singlet state is a couple paired of electrons. The triplet state is when there's unpaired electrons. So we have got that key. Okay, fine. Fluorescence work in the singlet state, fluorescence work, phosphorescence work in the triplet state. That we have known about the principle of fluorimetry that works on the principle of fluorescence to get the fluorescence of any compound by moving the and giving it the energy and moving it from its ground state to its unstable state, and by coming back to its stable state we get that fluorescence, and that we detect in an instrument or analyze in an instrument about the chemicals or the samples. So, and after that, we have learned about the instrumentations, the involvement of parts in the instrumentation. For an example, radiation source, then monochromators, then sample cells, detectors, and one thing which is important in fluorimetry is basically fluorimetry is instrument is in the process with a 90-degree angle. So the last thing is we have learned all this about fluorimetry. Like, then what are the samples or what are the things it can be used in? So basically, fluorimetry it's been used in the qualitative and quantitative analysis. For an example, determination of inorganic substances, determination of thiamine, determination of phenytoin, determination of indols, phenols, and phenothiazines, determination of naphthals, proteins, as well as there are other parameters also involved in this. For example, fluorimetry can be used in the detection of impurities present in any sample. That impurities can be in the form of nanograms levels or others. And last will be, it will be used in the aluminium, alloys, manganese, and other parameters involved with this. So when we cover this whole topic, and it has been used in respiratory tract infections and other things also. So these are all the application involved in fluorimetry. So this will be my whole presentation to you, and I think I have introduced my topic well, and I hope you have understood all the topic. Thank you for patiently listening to me. Thank you.